Okay, for today we're going to kind of start getting into these trig ratios that we did a little activity with in our last class. So if you remember when you guys had to use that GeoGebra website, you had to kind of figure out what those ratios looked like when you set them up. And so you kind of saw when we set like opposite over hypotenuse and adjacent over hypotenuse, no matter what the size of the triangle was, that they all kind of did the same thing. So we're going to continue to kind of talk about those things today. But we also talked about in that activity what a reference angle is. So remember, a reference angle would be kind of the angle that you're picking in the triangle that you want to be like your vantage point from, that when you're basing everything being like the adjacent and the opposite side. Remember, your hypotenuse is always going to be the same side regardless of where your reference angle is, because it's always across from the 90-degree angle. But depending on what angle is your reference angle, that's going to change what side we would maybe label as opposite and what side we would label as adjacent, okay? So when I look at these two triangles here, they're having me use two different angles as my reference angle. Like the first one wants me to use angle A. So I'm just even going to put like a little dot here by A. Let me do a different color. So they're saying like, what would you label the sides with if A was your reference angle? Okay, so if I'm looking at my triangle here, of course, across from that 90-degree angle box B, so this side AC, we would call the hypotenuse. I'm just going to put an H by that for the hypotenuse. Now, based off of my picture here, if I'm at A and I go directly across from A, so I go directly across this way, that would be my opposite side. So BC, I'll put an O by for opposite. And then remember, adjacent would be, adjacent means like next to. So when we talked about adjacent angles, we talked about two angles that were next to each other. They shared a vertex, they shared a side. So adjacent just means that it would be right next to the reference angle. So it's not going to be directly across, it's going to be next to that angle, which would be this side here. So I'll put an A next to that adjacent angle. Now, if I change my reference angle to C, so if I'm looking at C instead, how would you label your sides? What would be your hypotenuse for this one? Okay, so that's still the hypotenuse. Good. What would be your opposite side now? Good, AB. And then adjacent would be, yeah, B to C. Okay, so you can kind of see that the only thing that changed there was my opposite and my adjacent sides. So when your reference angle changes, the angle that you're kind of positioning yourself at, those two sides are going to be changing too. The hypotenuse should always stay the same, so that's not going to be changed at all. But it's just kind of good to be able to look at these pictures and know if I'm looking at this angle, this is how I would set up my opposite and my adjacent side, okay? Because as we kind of get forward and going into our notes here today, they're going to be wanting you to solve for missing sides and missing angles. And so we need to be able to know how to set these kind of things up, okay? We need to be able to know, how do I figure out if I need to use this trig ratio versus this one, okay? Now, there are three trig ratios that we need to talk about. You kind of explored a couple on that activity that you guys did, and you talked mainly about like sine and cosine, but we're going to talk about all three and what they look like. So the first one is sine, okay, and for an abbreviation, it's SIN, okay? I know it looks like the word sin, but we still pronounce that sine in the math world. So sometimes they might write it like this too, sine, and then they'll give like this symbol here. Just so you know, this symbol is talking about an angle, and it's the Greek letter theta. Sometimes in math, we use Greek letters to kind of notate certain things. So instead of putting in like an X or a Y there, they're using that theta symbol to kind of represent the angle that we don't know. Okay, and what sine is it's the opposite side over the hypotenuse side. Okay, and you could abbreviate it like this. If you want to stay consistent with what I did a little bit ago, you could just say opposite over hypotenuse, so like O over H. You don't have to write out opposite and adjacent and hypotenuse. You can abbreviate them either with a couple letters or with just a big capital letter, if that makes sense to you. Okay, so sine is always the opposite side over the hypotenuse side. Cosine, so cosine theta, is always the adjacent side over the hypotenuse. Okay, so A over H. And then tangent is always opposite over adjacent. Okay? So when we're looking at our trig ratios, this is how all three are always going to be set up. That will never change. And so how we determine what one we need to use, it's all based on what your reference angle would be. So when you're looking at your reference angle, like those pictures that we saw up above, if you're given measurements for the hypotenuse and the adjacent side, or the opposite side and the hypotenuse, or whatever the combination might be, that's going to help kind of lead you into exactly what trig function you should be trying to use. Okay. Now we have a phrase that we can use to help us remember how we would set up all three. Okay. And that phrase, it sounds kind of funny, but it's so ka toa. And so the capital S, capital C, capital T, those stand for sine, cosine, and tangent. And then the O's, the A's, and the H's, that stands for opposite, adjacent, and hypotenuse, okay? Another way I've seen this written is sometimes students will write it like this. They'll do a big S and then O over H for like sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So that's just maybe another way that you could write that. And for some, it makes more sense maybe to do that because you actually see the fractions that you're setting up. But either way, you're going to hear me reference SOHCAHTOA a lot. We're going to keep coming back to that as we're trying to set up our problems here to solve for whatever might be missing. Okay, so if you hear me say SOHCAHTOA, I'm trying to get you to think about what trig function are we going to try to use. All right. What we're going to start out with first is we're just going to practice writing out the trig ratio. So we're just setting up fractions that represent sine, cosine, and tangent based off of a specific reference angle. We're not necessarily solving for anything that's missing right now. So if you look at this first one, they're already giving you this triangle ABC, and they've got the sides all marked up. Okay, so we're not missing any of the sides. I don't need to figure out how much the hypotenuse or any of the legs are. Instead, what I'm just trying to do is set up my ratio, set up my fractions here. So to do this, I need to look at my reference angle. So this first column is sine, cosine, and tangent, all with respect to A. Okay, so A is my reference angle. So for right now, I'm just going to put like a little dot right there by A. I'm going to base everything off of that angle. First thing I would do is label your hypotenuse. Okay, because your hypotenuse is the one thing that we can count on that's never going to change. So the side that's across from the right angle, that 17, this is going to be your hypotenuse. I'm just going to put an H by the 17. Okay, now again, we're still thinking about SOHCAHTOA up here. Looking at A, if I'm doing sine, from A, what would be your opposite side? Opposite would be directly across. So where that 15 is, that's going to be opposite. So I'm going to put an O by the 15, okay? And so that would make 8 my adjacent side, okay? Now this is labeled in relation to angle A. When I change my reference angle, there's going to be a slight change that we have to do here, okay? But so sine of A, if I think about sine up here from my SO part, that's the opposite side over the hypotenuse. So my opposite side I said was 15, my hypotenuse was 17. So I'm going to put 15 over 17. Okay, now if I could, I would reduce this fraction. Now I can't take anything out of both 15 and 17, so I'm kind of stuck with it being the way it is. So I'm just going to leave it there. Okay, now let's talk about how would we set up cosine. Cosine is, think about SOHCAHTOA. We're in the ka part here. That's adjacent over hypotenuse. So we said the adjacent side was 8. So I would do 8 over 17. Again, I would check to see, can I reduce that fraction? I don't think I can, so I'm going to leave it there. And then we move on to the last one. The last one is tangent. So TOA, opposite over adjacent would be what two numbers? Good, 15 over 8. Okay, so that gives us all three of our fractions there. Now, if you look at the second column, they're switching the reference angle on you. So instead of it being at A, so let me just get rid of this, we're saying that our reference angle here is C. Notice how it says sine C, cosine C, tan C. So now my reference angle has changed. Is my hypotenuse going to change? No, 17 is still across from the right angle. So that hypotenuse is still going to be 17. But now if you look at the 8 and the 15, which of those two is my opposite side? Yeah, the 8 is. So I'm just going to cross off this A and I'm going to put this is opposite now, which means 15 would have to be adjacent. So you can see those two sides just kind of interchange when we switch from one angle to another angle. Again, we're kind of just switching our reference point, and so it's going to change the relationship that we see with those sides. Now, as far as setting up sine, cosine, and tangent goes, you're going to kind of continue to think about SOHCAHTOA to do this. So for sine, opposite over hypotenuse would say what? Good, 8 over 17. What would cosine say? Good, 15 over 17. What would tan say? Good, 8 over 15. Very good. Now just take a look at these. Do you guys notice anything here? Anything sticking out to anybody? Okay, so you're noticing sine and cosine, those fractions just kind of flipped positions, right? Yeah, this fraction and this fraction are the same. So sine of A is the same thing as cosine of C, and cosine of A is the same thing as sine of C, right? What happened with the tangent? Yeah, the fraction just flips over. That's called the reciprocal. So when you have a tangent function and you change your reference angle, it's just going to force that fraction that you have to reciprocal. It's going to flip it over. Okay. When you're setting up these fractions, this relationship is always going to happen. The sine and the cosine are going to kind of flip-flop when I switch my reference angle, and my tangent is going to reciprocal that fraction. Okay, so some of you will be able to start to see problems where you just go ahead and solve for one set of the reference angles, and then you use that information to help you figure out what the other ones are, because you can just kind of see those relationships. So what I'd like you guys to do is take a couple minutes and do this one by yourself here. Make sure, I'm just going to advise you, make sure when you're setting up your fractions that you check to see if you can reduce them. Okay, we weren't able to reduce on the last one at all, but make sure you check to see, is there anything that I can reduce these fractions by before you are all set and done? Okay, so I'm going to give you a couple minutes to go ahead and fill that out. Okay, let's go through this here. So I would start out by looking at your reference angle for X. So if you need to, you can just like put a little mark there. What side was your guys' hypotenuse on this triangle? Okay, and then from X, what would be your opposite side? Okay, so that means 27 would have to be adjacent. Good. All right, so for sine, how did you set up your fraction? Could be 36 over 45. Now, could you reduce that at all? you should be able to take a 9 out of both. So if you divide both of them by 9, this reduces to 4/5. And that's where I would want you to leave your final fraction, okay? What about cosine x? Okay, 27/45, good. How does that reduce? Okay, 3/5, very good. How about tangent? Good. And then how does that one reduce? Good. Okay, now if we switch our reference angle to z, 45 is still the hypotenuse side, right? But now 27 is opposite and 36 is adjacent. So they kind of just switch positions. Did any of you use the pattern to help you fill out the second column here? Like maybe you didn't set up all the fractions again. You could, but did any of you use the relationships that we talked about? Okay, tell me what you wrote down. Okay, second one then would be good. And then the last one was, yeah, very good. All they did there was they switched the sine and cosine ones around, and then tangent got reciprocaled. I guess I don't know how you would say that, but it as like a verb. But yeah, you just flip that fraction upside down. Very good. Okay, questions on setting up those ratios just as is? Okay, so now what I want you guys to do is down below, they're giving us a specific trig ratio that they used, and then they're giving us some sides, and they want us to find the measurement of the third side using the trig ratio. All right, so I would suggest when you guys do this that you draw yourself a picture. So we're going to do this first one together. So this first one is saying cosine of theta is equal to 10/26. What I'm going to do is I'm going to draw myself a right triangle down here. Okay, so I know that this is 90 degrees. It does not matter where you put theta at. So I'm just going to put it down here for right now. But I could have put it up in the other corner if I wanted to. Now cosine, think about the relationship. Cosine is what over what? Think about SOHCAHTOA. And what does A and H stand for? Good, adjacent over hypotenuse. Okay, so now let's think about if we're looking at the triangle and you're basing this all off of where theta is, what side on my triangle would get the 10? You're saying the one kind of down here at the bottom. Okay, so you're saying this is 10. Where would the 26 go? Right, across from the right angle, so this would be 26. Okay, what they want us to do is find the third side. So I'm just going to call this x. What's something that we've learned in the past that we can use to help us find the third side? Yeah, we could use Pythagorean's theorem, a squared plus b squared equals c squared. Okay, so let's set it up. What would go in for your a and your b? Good, the x and the 10. So x squared plus 10 squared equals 26 squared. Good. Now we just need to solve this. What's 10 squared? Good, 126 squared. Okay, what would you guys do next? Okay, and then how do we get rid of a squared? Yeah, we square root. Oop, I think I wrote the wrong number. That should be 576. What is the square root of 576? Comes out evenly, 24? Okay, so there would be that missing third side. Does that make sense how we did that? So use your trig function to help you kind of set up your sides, mainly to help you know like which one's your hypotenuse, okay? Or if you're missing the hypotenuse maybe, that way you can put in correctly for a squared and b squared and c squared, okay? So I want you guys to do the exact same thing here, but looking at this new one. This new one over here is giving you the tangent function. So I would start again, draw out your right triangle. And you can put theta down here, or you could put theta up here. It doesn't matter where you put it. You just got to pick an angle. If you want to keep it like what we did on the last one, then put it back down in that corner. Okay, take a minute or two here and solve for the missing side. Okay, let's go through this here. So I would have started by labeling. So tangent is opposite over adjacent. Okay, so from your theta down here, the 16 should have went across from that side and 30 should be here. We don't know in this case what the hypotenuse is. That's what we're missing. To set this up in Pythagorean theorem, it should have said 16 squared plus 30 squared equals x squared. Okay, when you square 16 and 30 and you add them together, you should have gotten 1,156. That equals x squared. And then I would square root both sides, and I got 34. Okay, does anyone have questions on how to set up those type of problems?